In this video, I'm going to solve some free fall problems. There's a couple things that make free fall problems a little different from acceleration problems, and we'll talk about those. So this problem is fairly simple. It says a 10 kilogram object, I'm going to underline that. That is a mass, but I'm not sure we're going to need it. Object is dropped from rest. So even though this is words, it's telling you that your initial velocity is 0. So a lot of times people forget to look for the rest or stop or something like that. And so if you see rest, that's a velocity of 0. And then it says how far, that's a distance, will it drop in 2 seconds? And seconds is a time. So the first thing I'm going to do is I'm going to write down everything they gave me. Okay, now some of it I might decide I might not need, like this mass. But some of it I might need, so I'm just going to write down everything and I can always cross out things that I don't need. So my mass was 10 kilograms. My initial velocity was 0 meters per second. My time is 2 seconds. And they did not give me an acceleration, but since we're talking free fall, our acceleration is always g, and it will always be 9.8 meters per second squared. So they don't have to give you g because you're supposed to have it memorized. And then the last thing they give you is they want the distance. Okay, now I'm going to write my formulas over here, and these are the same formulas that you guys have probably seen before. At least I sure hope you have, because if you're at this, you've pass the acceleration quiz, and you have to use these to pass the acceleration quiz. Except every time there's an acceleration, we've substituted g for that, because g is going to be our acceleration. It's acceleration due to gravity, and it's the acceleration we're going to use in these problems. And again, these are the exact same formulas you guys have been using, so hopefully you're getting a little comfortable with them. If they don't give you an initial distance, you can automatically assume it's 0. A lot of people actually just go ahead and take that di out completely because you don't need it a lot of times. Okay. And again, every time there was an acceleration, I just put a g in for that. But these are the exact same formulas. Okay. Now I have a mass, an initial velocity, a time, a gravity, and I need a distance. None of these formulas over here have a mass. So I'm going to cross out this mass because I don't need it. It's just extra stuff they gave me to throw me off. Okay? And they never gave me a final velocity, so I need to use a formula that does not have a final velocity. This formula has a final velocity. This formula has a final velocity. This one, it has a distance, initial, a time, a gravity. This one has no final velocity, so we're going to use this third one. Okay? Now, what I'm going to do is I'm going to plop in all the things I know. They didn't give me an initial distance, so I know that's 0. My initial velocity was rest, so I know that was 0. I'm going to write like this just so I can keep track of my units. Okay, this crosses out, it's 0. 0 times 2, that crosses out. And that leaves us with 1/2 times 9.8. Now these seconds cross out, and these seconds are squared, so they cross out. Meters, 2 squared is 4. That's going to be 19.6 meters. Okay, and that's all you have to do for this one. Okay, so the weird stuff was that we had an acceleration of 9.8 meters per second squared. They did not give us this, but we memorized it, so we knew it. Okay, you will need this for every free fall problem. You will need your acceleration due to gravity. Okay, so this was kind of an easy one. Let's do one that's a little harder.